So when we integrate, we get this plus c, but then sometimes the question gives us additional information which allows us to be able to solve for c. So here's an example. Okay? Well, here's the introduction. You've got the derivative is 2x, so the antiderivative is x squared plus c, but we would need more information to find c. This is what it would look like. It would say, okay, the derivative is 3x. That means my original function, if I integrate it, add 1 to the exponent and divide, that would be my original function, working backwards. But then if it tells us a point, in other words, it says it passes through the point 2, 6, I know that when x is 2, y is 6. This will be 12, but this is also 6. Getting c by itself, we figure out that c in this case had to be 0. So f of x is just 3x squared over 2. So because they told us a point on the original graph, we can plug that point in and then solve for c. So now what we have is just different ways of asking the same thing. The gradient of a curve at a point is another way of saying the slope at a point is the following equation. How do we find slope? That's your derivative. So now we know that our derivative is, if I write it this way, 16x cubed minus 3x to the minus 4. That would tell me my original function working backwards. Add 1 to the exponent and divide. Add 1 to the exponent and divide. Plus c. Now they gave us that it passes through the point 1, 4. You always have to ask yourself, where is this point? Is that point on my derivative? Is that point on my original function? So reading the question, a gradient of a curve, blah, 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 and passes through. So it's talking about the curve. That point is on my curve. It's on my original function, so I can plug in 4 for y. And 1 for x. Are you okay that I simplified the negative 3 over 3 and got a plus sign? And I moved the x to the minus 3 to the bottom, and I wrote 1 cubed even though I knew what the answer was. And so simplifying this, we're going to get negative 1 is equal to c. Find the equation now. We have to take the time to rewrite it. 4x 4 plus x to the minus 3 minus 1. So, should we make it a little bit more complicated? Yes. All right, here we go. Remember that notation? d2y over dx squared? What does that mean? That's the second derivative. So we have the second derivative. We have a point that's on the curve, and the slope of the curve at that point is 23. What's the equation? in our previous units, does it make sense that we went this way? F of x, then you found your derivative, then you found your second derivative. What did this question give us? It gave us the second derivative so we could work backwards and find our first derivative. And then if we had our first derivative, we could work backwards and find our original function. There's a couple of notation things in this one which are a little bit interesting. It's using Leibniz notation. So if I work backwards from d2y dx squared, I would get dy dx. Working backwards would tell me add 1 to the exponent and divide plus c. Now we could go back again, or we could take the time to find out what c is already. If we want to find out what c is, we would have to be able to plug something in for x and something in for dy dx. Do we plug in the point? No. The point is on the original graph. But we do know, what is dy dx? That's the slope. That's the slope at point P, and we know the x coordinate at point P. In other words, they tell us when x equals 2, because that's the x coordinate, dy dx is 23. So that means I can plug in 23 for the derivative. I would have 6 times 2 squared minus 2 times 2 plus c. And solving for c, I would get 3. So now I know the actual equation of my derivative, dy dx, 6x squared minus 2x plus 3. Now that I have the actual one, I can move back one step further and get y. Add 1 to my exponent and divide. Add 1 to my exponent and divide plus 3x. And now notation-wise, here we can't write plus c because we've already used a c and solved for the c. Typical mathematical fashion, mathematicians like to go to the next letter. It's like, oh, c is used up, let's use d. So we use a capital C, let's use a capital D. Okay, so you would lose a notation mark if you went to C again, because in this question, you already figured out C was equal to 3. So writing C again would imply that C is equal to 3 again. If I solve for this and C is 3, this means as a math teacher, I've done a bad job of choosing my variables. So I'm actually a little nervous right now. What do we know? We know we have a point. We know that when x is 2, y is 13. I can plug in 13 equals 816 minus 4 plus 6 plus d. Oh, good. Minus 5. And we can now write the actual final equation will be y equals 2x cubed minus x squared plus 3x minus 5. And we got a final equation. 2 more. I'll let you try them on your own. I'll put up the answers in a bit. Here is the rest of the work for the first one. Does it make sense when the initial population you'd put in a 0 for time? The initial part was driving you crazy. I know, initial. All right, how did you do? Oh yes, because it's a T. You need a DT in there.